This is our test review. Question 1. It states here that vector OR, and since we have O, we're starting from the origin, we're looking at position vectors, because position vectors start from what or where? The origin. So position vector OR, position vector OS, and position vector OT are position vectors with respect to the origin O. The coordinates of points R, S, and T are 3, 4, -1, 6, and 5, -2, respectively. So just as we call the letters or the points, we have the coordinates in the same order. So we can say this belongs to point R, this pair of coordinates belong to point S, and this pair of coordinates belong to point T. So we're going to utilize those in helping us. Now, write in the form of the column vector with components X and Y, the vectors OR. So position vector OR is the position vector of the point R, and point R is located at 3, 4. So the position vector will also have the same values for its components, 3, 4. OS likewise is the position vector of S, and the components will be -1, 6. And the components of OT will be 5, -2. In case you're wondering, we could just quickly highlight this. We have the X and Y axis. The X-axis is the horizontal axis, the Y-axis is the vertical. Now let's look at the location of point R. Point R is located at 3 units on the X-axis, so let's say 1, 2, 3, and 4 units on the Y-axis, 1, 2, 3, 4. So the location of point R will be right here. It has 3 units on the X-axis and 4 units on the Y-axis. And so since this is the origin where the X and Y-axis meet, we have the vector OR. So while point R is located at 3, 4, the position vector OR meaning starting from the origin right to the point R. So the starting point is O, end point is R. Now as a column vector, we'd have to go from R, O to R, we go on the X-axis first, then the Y-axis. So we move 3 to the right, and since it's to the right, it's +3, and 4 units upwards to finally meet at R. So we're going to put +4. So when we're going on the X-axis, to the right is positive, to the left is negative. For the Y-axis, when we go up, that's positive. When we go down, that's negative. That's the idea. But if we notice that point R has coordinates 3, 4, while a component of vector OR has the same values for its components, 3 to the right, 4 up, 3, 4, 3, 4. And so that's why we could look at point S with coordinates -1, 6 and simply place them as the components for position vector OS. Likewise, point T, the coordinates 5, -2. Vector OT, the coordinates being 5 and -2. And notice with all these vectors, they start from the origin. Now we're told that point P has coordinates 7, 5. So again, we have a point and its coordinates 7, 5. Write as a column vector of form, and we have A and B. Now they could have used X and Y as well. It doesn't matter which one they use. Okay, so we will just stick to the one they use, but it's the same concept. Now we want to go from R to P. Notice that with RP, we're not starting from the origin. We're starting from a point R. The origin is usually labeled with the letter O. Now what we do, we'll have a transit point. So it's like we have, let's say we have one country here, country A. We have another country here, country G. I have another country here, country T. All right. So you want to get from country A. So the airplane wants to get from country A to country T. But what it does, it travels this way instead. It goes to G first, and then from country G, it travels to country T. From Antigua to Guadeloupe would be A to G, and then from Guadeloupe to Turks and Caicos, we go G to T. But the ultimate goal is that we get from Antigua to Turks and Caicos, right? So this will be the resultant vector, AT. All right. So we also call this a triangle law of vectors, that we want to get from A to T, but we go from A to G, then G to T. This is like a transit point. You know, this is not our final destination. It's going from A to T. That's displacement, but we obviously travel from A to G, G to T. So likewise, we want to get from R to P. We can go from R to O, and then from O to P. So we're using now the origin as our transit point. Meaning, so if we have the x-axis, y-axis, and let's say we have point R here and point P here, we want to get from R to P. But instead of going from R to P straight, we'll go from R to O, in other words, to the origin, from R to O, and then from O to P, to point P. So to get from R to P, we use the root R to O, in other words, R to the origin and origin. For RO, components will be what exactly? Remember we said P is 7, 5, and so O vector OP will be 7, 5 in the column vector format. So RO, let's go back. Well, OR is 3, 4. So RO will be used the negative of those. Same numbers, 3 and 4, but just opposite signs. And OP will be 7, 5, as we discovered. And just in case you're wondering why RO is the opposite of OR, I mean, let's look at this. Let's say we have a vector here, right? We want to get from O to R. And we say OR, you go 3 units to the right. Maybe we have to travel along the X direction, 4 units up, right? Because our OR, it's 3, 4. So we go 3 to the right and then 4 up. But in case we want to get from R to O, we will go in a different direction, the opposite direction in fact. Remember, we want to go with it along the X direction first and then the Y direction. So we cannot go down. So what we do, we go to the left. Remember, now we want to get from R to O, the opposite direction. Where you see Y is -3, -4. So we go to the left, but notice it creates a parallel line to this one. But it's the opposite direction. And since we're going left, it's going to be negative. But the same distance as from here to here, right? Same distance from here to here is here to here. But to the left, that's -3. When we're going up is 4 units, right? +4. But now because we're going down, to get to O, it's going to be -4. Down is negative. But it's opposite sides have the same length. If you think about a rectangle, opposite sides have the same length. All right, that's what's created here, a rectangle. So while we go to the right is positive, going to the left is negative. While going up is positive, going down is negative. And so it'd be -4. Okay, going from, so we can see that RO will take the same numbers but different signs. Okay, so that's why we end up with -3, -4. And of course we want to simplify this. Let's simplify this. -3 plus 7 is going to be 4 different signs that we're adding, so we get different numbers with different signs. So we're going to basically subtract and keep the sign of the quantity that is further away from 0. -4 and 5. Because they have opposite sign, we're going to subtract, get 1, +1. Now if RP is 4, 1, then PR, okay, again similar to OR and RO, RP and PR will have the same numbers but different signs. Oh, quite easy, 1 mark. Now determine the angle that the position vector OR makes with the x-axis. So recall that OR has components 3, 4. And the formula for finding the angle that R makes with the x-axis is tan inverse of the y component divided by the x component. Now let me write that differently so you don't get confused. So the y component divided by the x component. Now this is just so you don't get confused with the column vector. I mean this format here. This is just that your calculator can work out the division first of the two components and then find the inverse of that answer. So let's plug that in our calculator. So we're going to have tan inverse. What's the y component? The y component is the second. Remember, the first is the x direction. The first is the x direction, the second is the y direction. So the y component is 4 divided by 3. And when we put that in our calculators, what do we get? What's the answer for tan inverse of 4 divided by 3? So I'm going to press shift on my calculator, tan, and then I see tan inverse comes up, 4 divided by 3, close bracket, and I get 53.1 degrees, and that's corrected to 3 significant figures. All right, you can always check our video out on significant figures. All right, so now let's look at question 2.